Hey, what's up, devs? Welcome to AJ Devlog. In this channel, we're going to tackle coding one challenge at a time. Today, in the Python string manipulation series, we're tackling the shift letters challenge. So let us understand the thought process and the code that we're going to implement in this challenge. So we want to write a function that takes a string and returns a new string where every character is shifted to its right by one place in alphabetical order. The considerations we have are that the last characters, when we encounter the last characters, small and capital Z, they should be replaced with the first ones, A and capital A respectively. If the character isn't a letter, it should stay the same. We are not going to use any string built-in methods in Python here in this challenge. So let's move to the thought process and breakdown to understand the problem. We want to shift every letter in a given string forward by one place in the alphabet. So for example, if you have the string ABC, capital X, Y, Z, small z, exclamation, A becomes B, B becomes C, C becomes D, so forth, X, Y, Y becomes Z, and capital Z becomes A. I missed a small z here, but that should have been a small a. And you can see the exclamation here remains an exclamation. Special case is where small z becomes small a and capital Z should become capital A. Numbers and symbols remain unchanged. Moving forward, we are defining the rules. Shift forward by one. Z becomes A. Capital Z becomes A. You can see some examples here. A becomes B. X becomes Y. Z becomes A. Capital Z becomes A. But if the character is not a letter, we leave it unchanged. Okay, you have a hash symbol here, remains a hash symbol. And number 7 remains a number 7. Moving forward, the approach that we're going to use for this, there are many approaches that we can choose, but for this one, I'm going to use the ASCII-based solutions, where we convert each character to its ASCII value using the odd function in Python. We're going to see how that is implemented. And then we increase the value by 1. And then we also want to check if that value is a Z. We handle the wraparound case so that Z becomes an A. Otherwise, we increase by 1. And then whatever the case, we convert that character back, convert that ASCII value back to its character using the CHR function. We'll see how to do that. So for this, we're going to use some constants. We're going to use the constants for lowercase a. When you use the ORD function on a character like A, you get the value for that character. Like in this case, it is 97. Lowercase z for small case z is 122. The odd a for uppercase A is 65, and for uppercase Z is 90. We also want to get the range between the uppercase and the lowercase character, whether it is, or rather between the uppercase and the uppercase Z and uppercase A, or lowercase z and lowercase a, which is going to be 25. We're going to see how to do that. So we're going to store the ASCII values for key letters, for those letters, and then the range helps us to handle the wraparound incident. Right, so let's see how to do that. Let's go to the editor. Okay, so we have the function here, shift letters. So as specified, we want to specify these constants for the ASCII values. Let me just bring them in, get them there. All right, so lowercase a, lowercase a here will have the value of 97. If I can bring up the terminal so that I can show you. Okay, let me do this terminal. Say man ASCII. Okay, you can see capital A is 65. and you can see capital Z is 90 in the decimal value. The decimal value for small a is 97, and the decimal value for small z is 122. So I'm getting just the a and the z, then because now we can use those ones to calculate anything in between those ones. Right. Okay, so we understand that capital A is 65, capital Z is 90. And then we want to get the range that we are going to use for the wraparound cases. In this case, we are using uppercase for Z and A. You can also use the lowercase, it doesn't matter. I just happen to use the uppercase. If you see for the uppercase, 90 minus 65, it gives you 25. So this value is very important, is what we're going to use for the wraparound. Okay, so I'm going to use a helper function to handle a function that will shift a single character forward in the alphabet. Let me call it def shift single, sorry about that, shift single letter. Takes in the character, which is a string, and it is also going to return a string. Okay, so this is as a, I'll just say helper function to shift character forward alphabetically. Great. It's supposed to be helper function alphabetically. Right. So the first thing we want to do is to convert that character to its ASCII value. That's if we go back to the steps here. We want to convert the character to its ASCII value using the odd function, the ORD function. Okay, so we say the character code is the odd of C. Okay, so we are getting the character value, the ASCII value of that. That's that string that we get, that character that we're getting in, right? Then we want to check. Let me just put in some, say, convert character to ASCII value. Then the next thing we want to do is to check if a character is a letter, either uppercase or lowercase. So check if character, in this case is ASCII value, should actually say check if character is a letter. So either uppercase or lowercase. Okay, so for that I'm going to have a long expression. So we say if the character is between lowercase a and uppercase and lowercase z, so if it is between a and z, or rather if it is between 97 and 122, okay, so say if character is between lowercase is greater than or equal to 97, character code, and lowercase z, which is 122, I'll break that up so that it spans so that it doesn't it's not too long. Or if the character code is between uppercase A and uppercase Z, so uppercase A, character code, oops, and uppercase. Okay, so we are checking if that character is either an uppercase or lowercase. We're going to define a variable. We call it, let's call it result. Result is the character code plus 1. Let's try and understand that. So for example, here, if we have an f, for example, a lowercase f, if it is 102, 102 is between 97 and 122. So if this is an f, it's going to be 102. We increase the value of that by 1 so that it becomes 103, which is a g. Okay, and then we store that in result, right? So we shift the data forward by 1 position. But remember, we want to handle wraparound cases just in case that value is a lowercase or an uppercase z. Okay, so we check if character code, we'll use the in function to check if it is whether in lowercase z or uppercase z. Uppercase z. Okay, so this one is saying if character is either z, lowercase z or uppercase z, then we handle the wraparound. We do, so now this result, whatever it was, instead of shifting forward, we alter it. We say result is the character code minus range. Character code minus range. Okay, so let's see if it is a z. Let me bring this up. If it is a z here, we have a 90. Let's just go here. So if the character is a capital Z, it's a 90. If we subtract the range 25, we'll get 65. So the result is going to get the ASCII code for capital A. If it is a 122, if we subtract 25, we will get 97. So that's what we are doing here. In this case, if it is a case or uppercase Z, we do a wraparound. Otherwise, result is going to be shifted forward by 1. Okay, so after I've done that, so whatever result the value of result will be, we return CHR for result. So what CHR does now, it takes, so let's say it is, we've done the wraparound, it's now 65. If we do a CHR on 65, we're going to get the character A. So it's doing the opposite of the odd function, simply. So we convert the character back to, let me say, convert the ASCII value back to character. And then here we can say check for Z or Z and wrap around. Awesome. So here we are saying if character code here is a lowercase or an uppercase, then you do these things. If that is not the case, then we say else. Actually, we don't even need an else block there, because if it is a lowercase, it will return. If it is not, we simply just return that character C. Okay, if it is not a letter, return it unchanged. Let me just do that. If character is not a letter, return unchanged. All right, so In this block here, if it is a letter, capital or lowercase, doesn't matter. We handle either shifting it forward by 1 or wrapping it around if it's the end letters. And then we return that one in the character format, not in the ASCII format. But if it is not, then we simply return whatever it is. If it is a hash or it's a number, we return that. So this is a helper function that we're going to use for that. I don't know if this is going to complain. Yep. So now shift letters. This is now where we're going to call this function for each character of that string. Let me just minimize this one so that you can see better. So we have a variable called shifted string, where that is going to return the new string where the characters are shifted. So in here, what we do, we're going to iterate through the string. So we say for character in string, shifted string, we append to it. Remember, strings are immutable. We cannot change the elements within a string. So what I'm doing here, I'm creating a new string and I'm adding to the end of it the character by character, depending on whether it is shifted forward or it's wrapped around, or if it remains unchanged. So whatever is returned from here, we are appending to the end to the end of shifted string. So shifted string, then we call in shift single letter, and then we are passing in the character. So once that is done, then we simply return shifted string. Let's see the output of this. So I have some test cases here. Let's run this. Hopefully there are no errors. Okay, so we see here A, B, C, B, C, D. 1, 2, 3 remained intact. X, Y became Y, Z, and lowercase z became A. Exclamation remains. So you can see for the rest of this, 1, 2, 3, 4, 5, 6 remain because those ones are non-letters, but anything that is a letter has been handled successfully. The time complexity for this one is O of n squared, for the fact that here we are doing a looping through, which is an O of n, but we are also doing a concatenation at the end of a string at the same time as we are doing a loop. So we're getting an O of n squared overall time complexity for this. That's it for today. Keep coding, keep improving. I'll see you in the next one. Please drop your solutions in the comments. I'll be checking for them to see what you guys do. Later, guys.